Hey guys, today we're going to be starting off talking about acid and base reactions. Can't talk about acids and bases without talking about the pH scale. pH scale basically is telling you how acidic or how basic something is. And something I'd like to mention is a lot of people tend to think that acids are bad and bases, whatever. They don't really know a lot about bases. The general rule is basically the further you get from 7, either getting to a larger pH, meaning you're getting more basic, or getting to a smaller pH, meaning you're getting more acidic, the further you are from neutral, equally, or the more dangerous it is. So a pH of 14 is equally as horrendous to the human body as a pH of 1 or 0. So, that's a good thing to mention is that, just because somebody says, oh, it's a base, it doesn't mean it's not dangerous. It actually could be even more dangerous than a lot of acids. So anything less than 7 is acidic. If it's greater than 7, it's basic. And if it's right at 7.0000000, then that means that it is neutral. If it's anything higher, it's slightly basic. If it's anything lower, it's slightly acidic. Now, what pH is actually doing, really up until this point, most of this content is stuff that you guys have probably learned before in other classes, whether it be biology or earth science. From here down might be new information. So what pH actually is measuring is the hydronium ion concentration. And hydronium ions are H3O ions. Okay, and I'm going to highlight that right here, H3O plus. Okay, now you may have heard that pH measures hydrogen ion concentration. Well, as soon as hydrogen gets released into the water as H+, it's going to combine with an H2O because, of course, oxygen being so electronegative and it being a polar molecule, it connects pretty quickly and that creates the H3O. H3O ions are formed when acids dissolve in water, so you have to have the acid actually coming in contact with water. And a good thing to mention is that the pH scale is a logarithmic scale, so every going from a pH of 2 to a pH of 3 means that it is a pH of 2 is 10 times more acidic than something with a pH of 3. So when acids and bases dissociate in water, or when they get into contact in water, they dissociate into their ions because acids and bases are kind of unique molecules in that they contain ionic and sometimes covalent bonds kind of mixed together. So you get kind of both types of molecules, or excuse me, both types of bonds in there. But overall, they're generally going to be categorized as ionic compounds. So you're going to find that hydrogen ions are released when acids are dissolved in water, and then of course whatever else they have with the hydrogen will also be released. And on the other side, the ions on that side as well will be released, including quite often, but not always, a hydroxide ion. So hydroxides are kind of an indication of bases, but it's really an old school definition because we've found plenty of substances that act like bases that do not release hydroxide, so we don't tend to think of that as being the way to memorize what an acid or a base is. But we do want to know what they dissociate into so that when we look at reactions, we can identify the parts and whether or not they came from an acid or came from a base. When acids and bases come together, they generally perform neutralization reactions. Now, later you're going to find out that there are other types of reactions that can occur with acids and bases, but the most common of which is the neutralization reaction. When acids and bases come together, they form what's called a salt. It doesn't mean that it's always sodium chloride, which is our table salt. Salt means the product of an acid-base neutralization reaction. So sodium chloride, sure, is in fact a salt by definition because it is a product of an acid-base reaction of hydrochloric acid and sodium hydroxide. But had it been something else, had it been potassium hydroxide and created potassium chloride, it still would have been considered a salt. Okay. Generally, the pH of the substance, of the mixture will neutralize over time as long as you get the correct molar ratio. Because remember, with stoichiometry, you have to have the right recipe to get the reaction to occur to completion. So in order to get a full neutralization, you would have to have the right recipe. Okay. One thing I'd like to point out down here at the bottom, I put a second diagram down here, just so that you can see where that water is coming from. Because we see that water and salt are the products, but the salt comes from the fact that we combine the ions right here, the Na and the Cl, and then the other ions, the H and the OH, combine together to form the H2O. Okay? So that's where it's all kind of coming from in a neutralization reaction. So I put it in this section twice, which means it must be kind of important that we identify that with acid-base neutralization reactions, we're going to produce salt and water. But one thing I really want to make clear to you guys right now is that what we're really creating here is aqueous salt. So we're creating sodium and chlorine ions. And again, this is assuming that the neutralization reaction is between hydrochloric acid and sodium hydroxide. Okay. Now, if it were between two different substances, a different acid and different base, then you would get a different product. Okay. You would still get water likely, but you would get a different aqueous salt. Now, when I say aqueous salt, I do not mean that we have salt crystals sitting in the water. Since it has created water and since chlorides are soluble, it's going to dissolve. So you're going to have what we call an aqueous salt, meaning those ions are going to be there. Ooh, those ions are going to be there. They're just not necessarily going to be combined. Okay, so you would still consider it to be salty water, and if you were to dehydrate the water out of it, you would still get sodium chloride crystal, but it is dissolved. On the other side, you get hydroxide. Okay, all right. Well, that is not what I wanted. That is just sabotage of some sort. You get hydroxide and you get hydrogen. And when they come together, of course, they create the substance H2O. Okay, so what I want you guys to do is make sure you review these notes because I am going to be asking you to make sure that you can identify an acid and a base given a neutralization reaction. I'm also going to be expecting you to know the pH scale very well. Okay. Next class period, what I want you guys to do is make sure you're prepared for a lab. We're going to be doing a neutralization lab where you're going to get the opportunity to neutralize these exact same two substances, hydrochloric acid and sodium hydroxide. So I want to make sure that you are prepared for that. Please bring your closed-toed shoes. And we'll also be doing some practice, so don't worry if some of the stuff that we're talking about here is not quite clicking because you haven't practiced it a little bit. I didn't want to give you too much homework, so you'll have it next time. All right, thanks.